Okay, hello everyone. Welcome to our hopefully final programming lesson. I've actually lost count, so I don't even know where I'm at, but certainly there's a number there. So we'll get right into it. I will be sharing my window of VS Code just to sort of get us started and give a little bit of a refresher as to what we were doing last time. So last time, I think, correct me if I'm wrong, I went over the specifics of what's happening here in terms of the code, and you guys understand the general structure, right? Like commands, subsystems. Subsystems hold the parts that we need to use. Commands use these parts in one certain way, and then I went through the rest of the files. It doesn't matter if you remember accurately, just do you remember the general structure and anatomy of the code? Please raise your hand if you do. Oh, I'm going to be annoying for a second. Don't be shy. You can feel free to burn me at stake. Okay, we've got two hands so far. That's great. Well, okay, it's fine. Even if you don't remember, I'm sure you can program it. I'm sure it'll come back to you. Okay, so we have about I think we have a few main things that are relevant in terms of planning out our code, and a few main things that are relevant in terms of planning out our robot. So, in terms of variables that are important to the code, we have almost all of the code, but in terms of planning out the robot, there are a few other things that are important and come in from real life, and we discuss those as the constants. So these are the things that are from real life, so the ports that we connect certain things to, and so on and so forth. So the perfect way, I guess, to get started in terms of programming is to get our interface with the user set up, right? So the user needs to somehow interact with the robot, and the best way we do that, or the most common way we do that in FRC, is to use an Xbox controller or a controller of some sort. We have flight sticks, but Xbox controllers are generally easier to use and drivers prefer them more. So we'll be working with Xbox controllers for now. So here we have, this is sort of the top of our class, right? So here we have our robot container. I think the tabbing is really incorrect here. I don't know if I can reformat it, or if I should just maybe if I, very quickly, sorry, I apologize. Tabbing is a huge pet peeve of mine. If your code isn't tabbed properly, prepare to lose marks. I'm like one of those people. Okay, there we go, perfect. Font size is nice. So yeah, here we declare sort of the variables, and oh my god, why is this in size 2? Sorry, my preferences reset. Now that we've declared our example subsystem and example command, we want to set, inside of our robot container, we want to set some way to interact with our Xbox controller. And to do that, we're going to make a new variable, and we're going to call this our Xbox controller variable. So, once you start typing in Xbox controller, if your IntelliSense is on, you'll get this pop-up right here for Xbox controller. Which is perfect because that's what we're going to be using. There's Xbox controller sim. I'll tell you guys how to set up for the simulator later. So don't really worry about that. We're just going to be programming it as if it's a real life robot for now. So once you import an Xbox controller over here, you'll see that this thing pops up on the top if you press tab. And that's just VS Code's intelligent way of sort of, it's called, I think, auto-importing or IntelliImporting or something like that. It imports the class for you, so you don't have to type this in. But normally you'd have to import the class first, and then you can make something of it. But here you can just do it like this. Next, we're going to give it a name, just Xbox controller, and we're going to make it a new Xbox controller. Right, so pretty simple. New Xbox controller. Now, you'll notice that there's one parameter here, and that's going to be our port number. Add a semicolon at the back. And that's going to be our port number. So the port number correlates to your USB port number. So the USBs on your computer are all numbered in some way, and it's really finicky to find out, but you can do it pretty easily by opening up the driver station thing. So it's more of a real life thing, don't worry about it. It's just we need a USB port number. Now, what if I have the Xbox controller plugged into USB port number 0 for the majority of my matches, and then the port breaks because I'm an idiot or something, or I drop my laptop and that port breaks? What do I do now? Since I might have to initialize USB ports at multiple phases throughout the thing, I'd want to make sure that it's something that I can change. I only have to change once. And how do we set something so that we only have to change it once? Do you guys remember what we learned last time, where we only had to change it once because of it? There's a special little nifty file that I'm hovering right over right now, so the answer is probably very obvious, unless you can't see my screen, though I think the resolution looks fine. Constants, yes. So our USB port, or the Xbox port, could be considered a constant. So the way that we can set a constant is just by doing public, and then we can make it final because we're not really going to update it, and we're going to call it an int, and we're going to call this our Xbox port. And since we're just going to assume that it's on USB port number 0, we're just going to say public final int Xbox port equals 0. And so now that we have this Xbox port set up, we're just going to go over here, and we're going to import our constants file. Right, so you can import it, using your frc.robot over here if you'd like to. So go like import frc.robot.constants, and that'll give you all of the constants that you need to sort of get your stuff set up. And so here we go, constants. So remember, constants is actually an object, and we're going to get our Xbox port from it. Oh yeah, it should be a static reference, actually not final. I'm done. Give me a second. So the reason we're making it static is because we don't want it to be copied over. We just want it to be one single box that's moved around through the file. So we're going to keep it as a public static, right? And the reason we're keeping it public static is because I think I explained the difference between static and final, but final is essentially something that isn't changed, and a static object is an object that the same object is used throughout the file. So whenever you call the object, it's the same thing. If your object isn't static, it's going to make a copy of it and give it off throughout the code, but we don't want a copy, so we're going to make it a static item. Okay, perfect. So we've gotten our Xbox controller set up. And you'll notice that when we start our robot container, or in the construction of our robot container, we run this configure button bindings function. And it says use this method to define your button command mappings. Buttons can be created by instantiating a generic HID or one of its subclasses, which is a joystick or an Xbox controller, and then passing it to a joystick button, which is exactly what we're going to be doing. So in this configure button bindings, what we're going to essentially do is we're going to say, oh look, so once this button is pressed on our Xbox controller, can you show where you import it? Oh yeah, sure. Did the screen? Oh no, I can still see the screen. Give me a second. Ah, there we go. We're back. So all the way at the top of your file, you have these things, and that's where you're going to add most of your imports. So right under the package, and right above this huge comment section. I wouldn't suggest getting rid of the comments because they really help your code, be more readable. Again, if they don't make sense, right? So if right here it says an example command will run in autonomous, it doesn't make sense. You can get rid of this, but these are generally important, just because it gives you a general sense of what the code is supposed to be doing. Though the names are pretty descriptive, not gonna lie. Anyways, once we're at this point in our code, we want to add in our Xbox controller and make sure that it starts working properly, right? And so the way that we're going to do that is by getting in our, let me just double check the reference because I think they changed it. Give me one second. Actually, I think I'm right. I mean, it'd be very difficult to be wrong in this situation. Yeah, you just instantiate new. Okay, there we go. We're good. We're good. All is well. So the way that we do that is we're going to make new joystick buttons. And we're not going to assign them to anything because we don't really need them to save. I mean, we do need them to save, but once we instantiate it, what it's going to do is in the construction of these joystick buttons, it's going to basically ingrain into the robot these commands. And it's going to say, once this button is pressed on this controller at this USB port, you're going to do one certain thing. And so this joystick button is, you don't need to save it because it's essentially getting ingrained into your robo reel. So you just need to say new joystick button. So you're just going to create a new joystick button. You don't actually need to do anything with said joystick button in terms of like saving it, because we're just going to be using it, a function of it or a command of it that'll set it up for us. So I'm going to add that semicolon. Actually, no, maybe not semicolon yet. So we're going to need our joystick, and the joystick is essentially just going to be our Xbox controller. So it's a little bit confusing, but we're just going to add in our Xbox controller as our controller, or our joystick, and we're going to need a button number. And so if I recall correctly, it comes from the button constant file. So we're going to import in something called button over here. So once you type in button, if you just press tab, it should be the first thing that pops up. So Xbox controller.button. Again, if you don't want to do that, then a longer way you can do it is Xbox controller.button. No, it's capital X, not lowercase. We're not talking about instance. Xbox controller.button. That's one way you could do it, or you can just import it in Xbox controller.button. Again, it really depends on how much you want to type. I just like doing it like this because it makes my life easier. So if we go to button, then once you do dot, you'll notice that these are all the different Xbox controller buttons. So I think you're used to them. You know, A, B, X, Y on the Xbox controller if you've seen one before. There's back, there's start, stick left, stick right, and so on and so forth. So these sticks are called buttons because, you know, you can press them in, right? I think this requires like a preliminary knowledge of Xbox controllers, which is interesting. But the sticks you can push in, so that can be considered a button, and the bumpers you can also push in. And so all these are considered different types of buttons. So we'll say that we want to run one, let's say, example command when we press X. Right, so the way we do that is first we have to reference the controller, which is going to be our Xbox controller. Then we need to reference the button that we're going to press, which is the X button, KX. And then we're going to do one thing with this. And the way that we do one thing with this is essentially we're going to do a dot on the joystick button, and this is going to run something that'll stay on our RoboRio. So you'll see that we have a few options here. We have toggle when active. We have wait, which will make the code wait for a while. We have when active, so while the button is pressed. No, when active is, I think, for the bumpers specifically. And then there's when held, which is when a button is held. When inactive, when the button isn't pressed. When pressed, so when it's just pressed once. When released. And you know, there are a lot of different options in terms of what we want to do. And there's also an and. So if you want to string together commands, you do it using the and function, which is really interesting. So we don't want to string anything together. We just want to do when pressed, and we want to run a command. So we want to do when pressed. It's going to give us our command, so we're going to run our example command. And interruptible, we're going to say it's not interruptible. And we're done. So, oh wait, no, this should be an instance of the example command. So I think they did m underscore example command, auto command. Perfect. So this is essentially going to be our joystick button creation. The constructor, blah, 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 is undefined. But it should be defined. That's weird. A button that gets its state from... Give me a second. Parameters, a generic, okay, so we got that. A button number, yeah, okay. The button number, yeah, that seems good. The constructor dot button. Oh wait, forgot one thing. It's button.kx.value. There we go. So we're gonna need the number value of the button, right? So just how your USB ports on your computer are named, the number or the buttons on your controller are also named in a sense, but they're given a number. So we're gonna get that number value. So it's button.kx.value. Perfect. So when we press this button, it's going to run our auto command. And that's essentially the first step of our introduction in terms of human interaction to it, right? So next, we sort of want to set up our drive, because I think drive is the main thing that most people look forward to when they're talking about a controller system. So I think this will probably run the entire length of the class. So I'll teach you guys how to make a drive, how a drive works, and so on and so forth. But beyond that, I will entrust you guys to finish the rest on your own, which I think I will try to show you. Okay, perfect. So let me just head over to subsystems, and we're going to make a new subsystem here. And so if you want to make a new subsystem, you can make a file like this. So we're going to call this our drive system. So I'm going to call it our drive.java. And so this is the subsystem that we will use to control our drive. Next, I'm going to take this subsystem code, and we're just going to copy paste it, because I don't want to write all the boilerplate, and the boilerplate already exists, which is why I like to keep that example file there. Next, you'll notice that the name is confused, because you can't keep the same name here. So I'm going to call this our drive, and it extends subsystem base. So that's the base. And you'll have to change this as well. They used to have a VS Code command to do this, but they got rid of it for some reason, so that's very unfortunate. Next, we have a few functions over here that'll just define how our subsystem will be used and what exactly will be contained within the subsystem. But that's not really relevant for us now. We just need to make so we need to define what's going to be a part of our subsystem, right? And so to define what a part of our subsystem is, we need to get exactly what our subsystem will sort of be using. And so in terms of a drive subsystem, what do you think? Resolve to a type Java. Joystick button. Did you import the joystick button at the top of your code? IDK. You should. Okay, maybe check that. That might help. And so yeah. So what, Rohan? We can help later. Yes, you have an error. What is your error? Just type it up. What is your error? Cannot make a static reference to the non-static field. So is your Xbox port variable public static? It should be public static. I think I corrected myself. It shouldn't be final. It should be public static. Apologies for the confusion that may have caused. Yeah, it should be public static. Public static Xbox port equals whatever value. Yeah, that should probably be it. Okay. So let me just re-explain it. Basically, in Java, there are many different types of variables, but when you're sending a primitive variable, like an int, or just any variable, when you're sending any variable through your code in Java, it gets sent in many different ways. There's a send by value, and send by value essentially means that's going to copy whatever the value of that variable is, make a copy of it, right? So a carbon copy, and it's going to send that carbon copy to wherever it needs to within the code. And so that takes a lot more memory, right? And so when you know that something is going to be used in your code a lot, what you can do is you can call it a static variable. And so a static variable, in exchange for taking more time, what it does is instead of making a copy, it's going to send that exact variable or that exact point in your memory where that variable is present. And it's going to send that throughout your code. So instead of sending a copy of it, it's going to send that exact variable all throughout the code. When it does that, it's going to change. When you change, let's say I send a variable called my number, and I set it, I give it a value 3. So let's say I send that to another part of my code, and in that part of the code, the 3 turns into a 6. Now, if it was a copy, if I sent it by value, then my number would still be equal to 3. But since it's static, my number would now be equal to 6 because I'm sending that exact variable and not a copy of it. And so the reason why we're doing static is because we want to send, because we want to assume that constants will be used a lot. And so to save sort of that memory space, we're not going to make copies of it. Yeah, that's basically why it has that error. Okay, I hope that helped. Coming back to the drive subsystem, what do you think would be an important part of a drive? So we can assume that a drive would have sort of 4 wheels, right? How are we going to control these 4 wheels? And what exactly... I think that's more of a mechanical question. I know I was surprised. I thought it was going to be a 4-wheel drive. It's not a 4-wheel drive. That's not your answer. If you thought it was a 4-wheel drive, you are sadly incorrect. Very unfortunate. Okay, I'll give you the answer. It's actually going to be something that's like a little bit of a drivetrain. So you have 2 motors, and these 2 motors move a gearbox, which moves a belt, and this belt will move your tires. So at least that's a simple way of driving. There are many different ways of driving, especially, there's like swerve drive, and there are a million different drive systems, but we won't be discussing those specifically. We'll just be working with a very simple tank drive, which is what we get in the chassis, or the kit of parts chassis. And so once we get into the swerve drive and other components, I will explain those, but that's going to be next year, not this year. So we're going to go with the very simple tank drive. That's it. So a tank drive will have 4 motors. I'm going to answer my own question. It'll have 4 motors. So it'll have 2 motors on the right and 2 motors on the left. And so we're going to basically consider, I think how I did it last year was I considered one of the motors to be the front and the back motors. And so I would just set each of those independently. And I think another way to do it is to sort of have a main and branch motors. 6-wheel drop center drive. Yes, yeah, a kit of parts chassis. Whatever. There are many different drive systems. So what we're going to do is we're going to make a very basic subsystem just with these 4 motors. And we're going to call them right front, right back, left front, left back. And that's just going to be sort of the 4 motors that we have in our kit of parts chassis. Again, you can have 6, you can have 8, you can even have like 12 for some random reason. But we're only going to be working with 4 for now. Very simple. So we're not going to make those variables here. We're actually going to set them out on the outside. And the reason why I set them out on the outside is so that they can be used throughout the code without confusion, right? So if I only make them inside this one function, which is this construction, then they can't be used elsewhere in the code. So we're going to set them on the outside, and we're going to give them a value inside the construction, just as we've always been doing. But before we get to that, I'm going to assume that we're going to be working with Falcon 500 motors. And so since we're working with Falcon 500 motors, it's going to be, we need to actually import those Falcon 500 motors and get their data. And so the way that we can do that is we're going to need to get a vendor library. And so that's a big fancy word. But I will, I think I have the link over here. Yeah, okay, perfect. I'll show you guys. So copy this link. I'm going to send it in the meeting chat. Please copy this link. So to save it to your clipboard or whatever you want to call it. And then do Control-Shift-P or Command-Shift-P, whatever you use. And then go Manage Vendor Libraries. Install new libraries online. Okay, don't do offline, do online install. I know this one will work offline because I have the files already, but just do online install. And then it says enter a vendor file URL. Paste the URL that you have in your keyboard and press enter. It is recommended that you build blah blah blah. Yes, just press yes. And so now what it's going to do is it's going to add your new dependencies. And so new dependencies is like new classes, new code that's coming in from online. And this is going to give us the ability to interface with Falcon 500 motors, which is the types of motors that we'll probably be using next year. And so it'd be nice if you guys could do that and raise your hand once you've gotten it done. You should have it build successful at some point. Okay, perfect. So my build was successful. Could I do that again? I could try to do it again. But yeah, sure, whatever. It's fine. So you do Control-Shift-P, keep saying and then you're going to go to wapilib Manage Vendor Libraries over here. And so instead of doing Manage Current Libraries, what you're going to do is you're going to click the Install New Libraries Online option over here. Then you're going to copy the link that I put in the meeting chat, and you're going to paste that in over here. And then once you do that, you're going to press Enter. I've already done it, so I don't want to install it twice, so I'm just going to press Escape. But you press Enter in that situation, not Escape. And yeah, once you guys have done that, please raise your hand to let me know. And we can continue along with making our drive system, which is fun. Much fun, much fun. Maybe this... Okay, if you have a question, put it in chat. That should be good. Yeah, you use the online one. If you do the offline one, it's going to go to an installer thing. It's going to be weird. So online one is good. Now, online one has a few caveats, which is... caveats, which is essentially it won't work if you're offline. But the thing is, that's a problem for the main robotics laptop to worry about, so we should be fine, because they're almost always online. Unless like the world ends, but we're not going to be running an FRC league once the world ends, unfortunately. So we have one person who's gotten a build successful. That's good. So one more than zero, you know. We've got two, okay. Failed. What part did it fail on? If you don't mind, could you just share your screen very quickly? Like, show what it failed on. I can stop sharing mine. Yes, you're supposed to click yes for the build. Because if your build failed, that means that there's another larger issue present, so. Ah, okay. Terminal process, build failed. Did it give the exact information as to why? Maybe do like a debug. Or stack trace. Yeah, stack trace would be good. Oh, it's in your drive.java file. It seems like you have an error. That's probably why I didn't compile the Java properly. Oh, yeah. Yeah, you just have an overhead. If you just copy the code, it should be good. Unless you deleted the file, in which case, that's unfortunate. Okay, I think I have to stop sharing and reshare to pin it manually, because that's how it works. Okay, so we've reduced the number of hands, but it's okay. I'm gonna assume that most people are good. Again, if your build has failed at any point or if anything didn't work, just let me know. But I'm gonna continue at this point because I want to hold people behind, and we are at about the halfway point, so we should be a little bit careful as to our time usage. Okay, perfect. I'm good to go. So, there are two ways. I think I sort of mentioned this. There are two ways to control our motors or to wire our motors. I mentioned this in the electrical meeting, so I'm getting it mixed up. I don't know which one I mentioned where, but the way that our Falcon 500 motors are set up is a way called CAN, right? And so CAN, it typically has its own sort of usage. Because it's very dependent on the type of motor you're using. The way that your motor deciphers the language of the CAN bus is basically how the motor is going to work. That's why we need to import these external libraries, because these motors aren't made by Wapai, or I guess first, they're made by other people, and especially Crossroad Electronics. And so I'm not going to import it outright because I think it's easier if I just try to do it over here. So we're going to get our Wapai underscore. Did it not refresh that? Okay, hold up. Might have to do it to here then. Import com.ctre.phoenix.cam. Okay, there we go. Perfect. If you import that, you should be able to get these loaded up. So we're gonna get our. Is it Talon FX or is it Falcon 500? Dot can dot base Talon base Falcon. And I cannot find it. A, B, C, D, E, F, G. Wonder if they have not updated it yet. Oh yeah, I don't know. What? Oh, okay, okay, yeah, that makes sense. Yeah, okay. So because the documentation reference will. Okay, yeah. So Talon FX will be the motor control that we're using for our Falcon 500. Do not worry about it. Next, once we've defined the sort of class type, we're going to make all of our motors, right? So we want a right front, we want a right back, we want a left front, and we want a left back. Left back. Perfect. So once we've gotten all four of these set up, this we don't actually have an instance of it. We just sort of give it a name. So we're going to have to actually create the motors, and we're going to do that inside of our construction function. And the reason why we don't do it here is because if we do it in our construction, we know where exactly it will fail, and we also don't double create it, or we don't allocate the pin twice, right? And so what I mean by allocating the pin twice is each of them are connected to one electronical pin, or in this situation, they're connected to one CAN location. And so once we have that CAN location, if we try accessing it 2 times, so you try accessing it from the outside and from somewhere inside of these functions, we're going to cause a conflict. And so to make sure that we only do it once, we're only going to call it once during the construction of our drive subclass. Wow, that's been tabbed a lot. Perfect. So we're going to initialize our right front first, and we're going to say it's a new Wapai Talon FX. It's going to give us a device number. Remember, CAN device number. And so, this number might change a lot. And so to make sure that we can allocate for those changes, we're going to go back to our handy dandy constants.java file. And we're going to add that in. So we're going to add in our public static int right front port. And we're going to say that our right front number. And we're going to say that this is 3. We're just going to go 3, 4, 5, 6, 7. So what we're going to do here is by Talon fx. And we're going to go constants dot right front number. Perfect. So now we've imported our constants, and we want to do the same thing for all of the rest of our motors, right? So right back equals new Wapai Talon fx, and then we're going to get in our constants dot. Oh, I haven't made that yet. Ooh. And then maybe left front, we do want a different, because the numberings are really weird. Whatever. This is very unrealistic. The numbers will be very weird, not organized like this. Which is unfortunate, but that's just the way of the world. Oh, didn't add an equal sign here. Okay, perfect. So now we have all of our ports set up, so we're just going to add them in over here. Redundant programming could probably be done using copy pasting, but copy pasting is for lamoids. Says me. Left front number. And this one is left back number. Okay, perfect. So we have all of our motors set up. Perfect. So we have our right front, right back, left front, and left back. Now, in terms of programming it beyond this point, oh wait, let me know once you guys have reached this point, and then I can sort of move on from there. But in terms of getting to this point, there are two ways we can go. I'm gonna go the harder, more homebrew way, and the reason I'm doing that is so that we get more control and you guys actually learn more about how it works. But there's obviously a higher level and easier way of getting this set up. So you can choose whichever one you like better. I just prefer to make things harder on myself for some reason. But yeah, I'll teach you the other way as well if we have time. If we don't, it's whatever. You know, it's fine. This way still works, and in fact, it's a little bit better because it has more modularity. So if you are not at the step, please let me know. If you are at the step, then just sit tight. Okay, Priyanshu, are you just raising your hand because you are at the step, or you're not at the step? Because I'm very confused as to the system that I made here. Not at the step. Okay. Yeah, so is it just typing or is it anything else? It's just typing. Okay, yeah. I'm just going to introduce the next part because it's more redundant typing. It's fun, whatever. So we're going to make, what we need to do is, once you have these motors, we're going to have to set them in a default mode, right? So technically, it's like a car, if you've ever been in a car, if you've seen someone drive a car. You know, cars have a neutral mode where it sort of has no impact at all. That's going to be the neutral mode in terms of a car, right? But you typically don't want it to be in neutral mode, especially when you're parked somewhere. You don't want your car to be parked in neutral mode. And just the same, when we're actually moving our robots on the field, we don't want our motors to be in neutral mode. We want them to be in brake mode. And so when they're in brake mode, if we're not moving the motors at all, they will completely stop and they'll force themselves to remain at zero, right? So if we're on an incline or something, the motors will force themselves to remain at zero, which will prevent our robot from moving backwards or shuffling at all while it's neutral. And so what we need to do is we need to set the neutral mode. And luckily, there's this function called set neutral mode. It's almost like they made this so that people would expect it. So when we're setting neutral mode, we're going to need our neutral mode sort of constant. And so the neutral mode constant is going to be brake. And so if you type out brake like this, I'm pretty sure it'll pop up. It's going to be neutral mode.brake. And you're going to do this for all of them. I mean, some of you might have put this in an array or something. You could do that. You could very much do that. I don't know if you really want to do that, though, because of all the different things that we'll be doing. But you could do it. Neutral mode.brake. And then we're going to do the same thing for our left front. We've got set neutral mode dot brake. So yeah, there's coast and there are a few other things. So we're just gonna set it to brake because we don't want our robot to move. Not brake like brake, but brake. I'm sure you could read. You know what? I'm not gonna explain myself. Okay, perfect. So now we have all of our setup done. So I'm sure that you guys can do this. I don't think it's very difficult. I mean, typing can be difficult at times, so. Definitely have been in that situation before, but I don't think it'll be that bad, so I trust you guys to do it. Okay, yes. Once you're at the step, I don't know. Okay, if you're not at the step, please raise your hand, and please lower it once you're at the step, like once you've completed it. Did you guys know you can make a vacuum with your hands? It's so sick. I discovered it the other day. It's like if you like clap your hands together, it's like this, and then it sounds like a fart once you let go, but it's actually sick. Cause it's like my new favorite pastime, actually. I know. Thank you, Andrew. I take pride. Yeah, whatever that was, the drip sound effect. Okay, I'll just be quiet now. Did you? Yeah. I don't know, man. I really don't know. I ask myself that question a lot. Okay, whatever. Let's continue. Take soap. And you go, whoa, yo, really? Hold up. I need to try that sometime. Okay, whatever. I'll try it sometime later. Okay. We need to get back to program. We have about 20 minutes. Okay, so before we actually move our motors, we need to make sure that we can stop our motors in the case of an emergency. So we're going to make a stop function. And the stop function will essentially stop all the motors from moving at all. Or maybe I should do this last. I think that'd make the most sense, actually. Yeah, that'd probably make the most sense. So, maybe, you know what? We'll just do that. So we're going to make two functions, and they're going to be to set the individual speeds of our left and right sides. And so, since we're not returning anything, we're just going to be setting their speeds. We're going to make one called set left, and we're going to take in a double value, and we're going to call this the speed. And then we're going to do the same thing, and we're going to make one for the right. Set right double speed. And so, now, let me try to explain what the double speed thing means. So, well, maybe I should add encoders. Actually, this was made before encoders. Armand, adding encoders would be smart, right? Okay, encoders are good. Yes. So, I'll add the encoders very quickly before we actually get to setting the speeds. But all you need to know about setting speeds is that they basically work in a way where you have 1, which is the highest possible speed in a forwards direction, and -1, which is the the highest possible speed in a backwards direction, right? And so your speed is going to be 1 decimal in between the two, right? So you can think of it as something as a percent. You're moving at 90% capacity, you're moving at 0.9. You're moving at 100% capacity, you're moving at 1. You're moving at 70%, you're moving at 0.7. 75, 0.75. 6492, then you're moving at like whatever percent you're moving at, right? And so it has to be in that range, and that's how we're going to set our speeds, which is why speed is a double. It's not a double because we're setting it in terms of like speeds in miles per hour. We're just setting it as a percent of how much capacity the motor will be outputting. As a general rule of thumb, your motors should never really be outputting 100% power because that'll burn them out really quickly. So we typically keep a maximum of about 0.7, maybe 0.75 in a very difficult use case. Oh, I got a missed call. Oh, that's fine. But we're going to be setting up our encoders now. So I had the documentation open there, but I'm going to open it up here very quickly, just so that I can give you guys accurate readings as to what I'm talking about. Encoders hardware, encoder software. Perfect. Okay, so encoders are basically fancy little devices, and the way they work is once you spin it, or once you spin an encoder, or once the encoder starts spinning, it's going to start sending out ticks once it reaches a certain point. And so these ticks, or I guess these points or pulses, will essentially correlate to how much it is spun, right? So depending on your wheel diameter, if you think about it, if you have a really large wheel, once you spin a little bit, or once you spin, if you have a really small wheel, like if you're just talking about the encoder itself, right? So think about a wheel that's maybe like an inch in radius, then if you spin a little bit, it's going to hit that tick really quickly. But if you have a really big wheel, you can spin a lot before it hits that tick, right? And so we don't know exactly what constant that is, and especially in the code, we don't know what constant it is. So we need to measure it out ourselves, but this tick in the sensor is really useful to us. So physically what we can do is we can move our robot, and once we move it, we can move it to about 1 meter. And then we can count how many ticks have occurred from our current moment to that 1 meter. And so by counting that, we can essentially get a rudimentary sense of distance, right? So if it's 3 ticks per meter, then if we want to move 2 meters, we just need to move 6 ticks, right? And so that sort of allows us to get a rudimentary sense of distance. Does that make sense to you guys? Like the use of an encoder and how it helps? I should say to you people. People are inclusive. Folks, maybe, with an X. But people do that now. Did you know that? I know that. I knew that, I think. I don't know. When was the first time I heard it? Okay, whatever. I'm assuming it sounds cool to you guys, because I was actually blown away when I first heard it. I was like, oh my god, this is so cool. Why have I never heard of this? So, we're actually going to make our encoders, and so we're going to set the pins that our encoders will be using. And so we're going to do that in our constants.java file over here. And so it's nice to add some spaces. There's some spacing in here, just so that it makes a little bit more sense. So with our motors, we keep this here. And we're going to add our... So encoders take 2 pins. I think it's like input-output pins. I forget. But we're going to call them basically... We're going to make left encoder pin 1. And we're going to call this, whatever, 0. And then we're going to make one for our pin 2. Left... No, we got left encoder pin 2. Oh, no, 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 no. And we're going to make this 1, and then we're going to make one for our write. Public static int, write encoder pin 1, and we're going to call this 2, and just go in numerical order. Again, in real life, you're probably never going to get perfect numerical order because it's really it's not a kind world. But I mean, we can imagine that things go well for us here. Okay, perfect. So now we're going to make our encoders. Obviously, we're going to make them up here so we can use them throughout the rest of our code. And we're going to call one our left encoder, encoder, and we're going to set this to be. We're not going to give it a value, and we're going to make our right encoder as well. Perfect. And we also need to import our encoder. So hold on, let me just do that very quickly. That's it one. There we go. Perfect. So we notice that it gets imported over here. That's good. Okay, so now at the bottom of this, we're going to initialize those two. So we're going to say left encoder equals new encoder, and we're going to need our channels, I guess. Yeah, channels. And so we're going to set our channel A and channel B to be whatever values. So we're going to go constants dot left encoder pin 1. And these are essentially like the electronic communication panel, so the pins that it's going to be using. Right encode. Oh no, this is left encoder pin 2. And then we're going to say right encoder equals new encoder. I've been saying the word encoder a lot. I don't know what else to say. It's just encoders. And we're going to get our right encoder pin 1, and we're going to get our right encoder pin 2 as well. Dot right encoder pin 2. Perfect. So we've gotten our encoder set up, and they're over here. I don't think there's any initial setup we have to do in terms of the encoders and getting that. Actually, no, I think there is. Yeah, so there's set different things, set reverse direction, set pulse. So there are lots of configurations we can make, but one important configuration we have to make is set distance per pulse. And is there anything else that's relevant? No, it's just set distance per pulse. Yeah, okay, so set distance per pulse is probably going to be the most important thing. So distance per pulse, I think this is in feet, because this is American. Or maybe, oh, useful units. Yeah, it could be anything, right? So if you're talking about like distance per pulse, you can essentially say 3 meters per 200 pulses, or whatever thing you want, right? So we just want it to be some sort of a unit. And so to make sure there's some sort of a unit, let's say that we move 2 meters for every 232 pulses, right? So there's going to be some sort of a constant, right? And this constant might change. Let's say we change the wheel size, the constant changes, right? And so because of that, because this constant can change, and because it's a constant, we're going to make this a constant over here. And we're going to call this distance per pulse. And we're going to set this to, let's say, 2 divided by 300, or maybe 2 divided by 232. Perfect. So this is essentially going to be the distance that we go per 232 pulses. So this is going to be our distance per pulse. And it's going to take this unit, and it's going to, extrapolate it to move a certain number of units for each thing. So this is going to be in meters. Maybe I should do that. Distance per pulse meters. Right? So here, we're going to go, and we're going to get this from our constants. Distance per pulse in meters. Perfect. And we're going to have to do the same thing for our right encoder. Dot set distance per pulse constants dot distance per pulse meters. Okay, perfect. Now, when we're setting the speed of our left and right, it's really, really simple. So what we have to do is we just have to, if we're setting left, then we're just going to go for our left front motor. And remember what I said about setting it to a speed? We're basically just going to set it to that speed. So once we have our speed, our double speed, we just put a speed over here, and boom, we're done. And we're going to do the same thing for our left back. Maybe I should have done left rear. And you're going to do the same thing over here. So I'm going to go right front dot set. I'm going to set it to the speed. We're going to do right back dot set. We're going to set it to the speed, and so on and so forth. Okay, perfect. I hope that helps. I spelled right back incorrectly. Next, what are some other useful functions that we would probably need to set up here for a drive? It would probably be the tank drive function. Oh yeah, okay, so drive right for a certain number of time. drive left for a certain number of time. Okay, I did that. And then there's the dot drive function. Okay, perfect. Spin left, spin right. That's not relevant. Okay, yeah, sure. So we don't necessarily need the spin functions. We can just very quickly make a drive function since we're running low on time. So this drive function will essentially just drive our robot. So we need a double left speed, speed, and we need a double right speed. Right, okay, so we take these, and we're going to basically do set left to our left speed. Where is it? Left speed. And we're going to set right to our right speed. Obviously, we could incorporate our encoders in here. I really did want to, but I don't know if we have enough time because it's already 3:51. I want to hold you guys back. So I'm just going to very quickly show how we could set it up just in case we run out of time. So I'm going to save all of these files because they're pretty important. So save it because we're basically done with it. You don't really need to do much. Oh, I forgot the stop function. How could I? We're going to have to stop them. So in the case of an emergency, we could have a stop function, right? So maybe we just need everything to stop just for the sake of safety. One way we could do it is we could set left to 0, and we could set right to 0, and that'd be the easy way to do it. But we're not doing the easy way. We're going to do it the difficult way because I love taking up your time. So we're going to do left front dot stop. Stop motor. There we go. And we're going to do the same thing for basically all of them. We're just going to stop motor. And so the question arises, what's the difference between the two methods? And so from what I gather, I don't know if this is true or not, but I'm pretty sure it's what's happening. Stop motor will stop all activities of the motor, basically from the root, while setting it to 0 or setting it to 0. Setting it to 0 will essentially still keep it active, but just set it to a speed that is at 0. So that's kind of the difference between the two. One will stop all activity, while the other will just set it to a speed where it isn't moving. Obviously, speed where it isn't moving is the same thing as stopping, but it could be a little bit different. If there's an offset in the electrical signals, or if there's some difference, then it probably might not perfectly stop it. And so that's probably a good reason why we would use the stop motor function instead of just setting the speed to 0. Though I'm pretty sure they're interchangeable. This is just extra safety measures for safety's sake. Okay, perfect. So we've made all of our things over here. And that's good. So we've made all of our commands from our thing over there. I don't necessarily think we need a command to run our subsystem, though I should probably teach you guys how to make a command. That might actually come next lesson. So you know what? We ran a little bit short on time, so next thing I'll teach you guys how to make commands and stuff. Yeah, I think I have to do that. Or maybe very quickly I can make a command for the drive. So, okay, very, very quickly. How quickly can I do this? Okay, let's go. Let's go. We can do it. I'm pretty sure. You guys can stay like an extra 2 seconds, right? So make a new one. We're going to call this our tankdrive.java. This is going to be our new command. So copy all this essentially, because we're going to be using it, and send it over to our tank drive over here. Command V. Okay, perfect. And so we need an example subsystem, but we're not using an example subsystem. We're going to be using our drive subsystem. So we're going to pick a public final drive. And we're basically going to gather in drive from here. And what's one other thing we need for a tank drive? What's one other piece of input we need from the user for a tank drive to work? So I thought it'd be relatively obvious. It's a controller. It's a controller. Yes, we need a controller. So we're going to say, oh wait, no. This is going to be our inputted drive, so I can add an underscore in the front. It's going to say drive equals drive. So we're going to input this drive. We're not going to make a new drive. Again, port conflict. We don't want it to be getting the same electrical signal. We also want another sort of, I'm going to call this tank drive. I think that's the name I gave it. Final field has not been initialized. Right. So we're just going to make it private then. So private, and then we're going to make our Xbox controller, and we're going to call this just controller, I think would work. Controller. Okay, perfect. And now we're going to get in that, and we're going to get in our Xbox controller as well. And these are going to be the two sort of parameter we need. We're going to say our controller, and we're going to set the name to this to tank drive, and we're going to say that our controller is equal to our underscore controller, or the inputted one. And we're going to add our requirements, right? So this is going to be the requirements over here, and we need drive, and we need our controller. I think those two are essential. Maybe just a drive subsystem. Yeah, I don't think you need another thing that's here. Maybe it's just subsystems. It is subsystems. Okay, so in terms of initialize, I don't think we need to do any initializations because the drive will already be set up. But to execute it, we want it so that it will move, or it'll drive the chassis, or it'll drive the drive system. So we'll do drive.drive, great naming system for me, and we need to get the left and right speeds. So we basically need to, great. So we basically need to get our the 1 to -1 from our joysticks, right? So if we move our joystick up or down on the y-axis, we want to get that 1 to -1. So that's basically the speed that we're going to get. And to get it from our controller, we can just do controller.get, and I think it's get y. Yep, it's get y. And so because tank drive is on both axes, we're going to have to get y based on a hand. And so this is going to be our hand, which is going to be from generic HID.hand, and we're going to get it from, say, we're going to drive left with our left hand, and we're going to get controller.get y. And in terms of, oh, whoa, what did I do there? I added a breakpoint. Okay, please don't add a breakpoint. We're going to get our y from our hand.k right. And so you'll notice that it auto-imported hand, so it pops up right over here. And that's going to be sort of what we do while, so every time the scheduler runs, while this command is on, we want it to move that controller, right? And so since we want that to happen, this is all we need to do for the execution. We just need the drive to move based on these results. And when it ends, remember, we just want our drive to stop. So you just want everything to stop over here. And that should be good. We don't really need an is finished because this will basically always be running when we're running teleoperated. So just save your tank drive over here, head over to robot container, and now we're going to bring in one of our newer files. And we're going to drag it in over here under our example subsystem. We're going to make our new one. So private final drive equals new drive. Perfect. I don't think we have any initialization variables there. And then we're going to add our Xbox controller probably up here. Very quickly, I apologize if this goes a little bit over time. I'm very time conscious at this moment. Then we're going to make our tank drive command. So this is going to be our private final tank drive equals new tank drive. And remember, the two variables that we need for our tank drive are going to be our drive and our Xbox controller. Perfect. So we've gotten all of it basically done. And so in our robot container, because we're not going to bind this to a button, we don't want a button to turn on our tank drive, we're basically just going to set it so that it's a default command. And so the way that you can set it to be a default command is drive.setDefaultCommand, and we're going to set the default command of our drive to be our tank drive. And that should, I think, if I recall correctly, that should be it. Yeah, I think that's it. So now if you drag this onto a robot, and your robot has all the ports set up in the right places, you should be able to basically, yeah, you'd have it all done. Congrats, we made a robot move. And we did it all before 4 o'clock. So if you have any questions, very quickly, please relay them. Can I post? I can post a zip of this entire thing if you'd like me to. I can post a zip on the classroom. So I'll do that, actually. That'd be great. Okay, I'll do that. Okay, yeah, so if you have any questions, please let me know. If there are no questions, then I guess see you later. I hope you enjoyed this. Again, always open on the Discord, and apologies for the time constraints. We will have to have one more lesson, or one more class, or one more. Vraj gets to suffer trying to plan this, but he doesn't plan it at all, so it's completely impromptu. That's why it sucks. You guys can leave now. about the triggers, about using triggers instead of joysticks. Oh. If you want to find that out, well, you can't really move backwards with those, right? But if you really want to, I'll show you how to set that up. Oh, something fell. Something fell. The way that you can set that up is if you do controller dot get, I think it's trigger, yeah, get trigger axis, then you basically get the yeah, return the trigger axis value. And then yeah, so you just have to get trigger axis based on the hand, and that should do everything for you. But that's only like one side, right? Just because, yeah, it does not mean you should. So the way that you'd have to do that is you'd have to get like left and right. Let's say I was doing it reverse. This is going to be a very quick like sort of lesson. So we're going to make a left left bumper, and we're going to say this is our controller dot get trigger axis, and in terms of the hand, we're going to do hand dot k left, right? Then we're going to get our right bumper. Maybe I should just set these to be well, whatever. These are not bumpers though, so I'm technically wrong. There we go, that's good. And you have to probably set the right as your negative, because, no, wait, right would be positive, left would be negative. Controller dot get trigger axis hand dot k right. And you'd have to combine the two in a case where basically it's going to be, I think it'd be dependent on the majority, and then you cap it, right? So if you're pressing both of them at the same time, you just don't want your robot to move. It has to be one or the other. So if left trigger greater than 0, well, you need a margin of error too, right? So greater than 0 minus or 0 plus, and then we'd have to define a margin of error here. So huh? Yeah. So you know how controllers like slowly rot over time? Yeah. Yeah, perfect. Okay, so you'd have to have a margin of error, and we can call this like 0.04 maybe. We don't know what the margin of error would be, but then we add that over here. So constants plus margin of error, and then we have to do the same thing for the right one. Right trigger greater than 0 plus constants dot margin of error. Then it just doesn't do anything, or else, yeah. So you'd have to continue along that route. But yeah, that's how you'd use the triggers. You'd have to combine them together, and depending on what side it is, you'd have to use that side, right? So if I'm just pressing down the right, then I move in the right as a certain direction. If I'm moving the left, then I do negative of the left value. Does that make sense? Yeah. Oh yeah, well, that's true, but you should maybe, I don't know, whatever, just in case. You'd probably do like an else if left trigger 0 plus. Maybe I should make this a function. That'd probably make more sense. And then this would be like drive.drive, and then not even drive.drive, it'd be drive.set left or something. Maybe this is the left motor, and you do negative left trigger. And then you do like if it's right, then dot margin of error. Then if it's the right, you're going to do drive.set left, and then you're going to do right trigger. I can't see this because I have to move this thing. Okay, there, perfect. So yeah, that's probably how you'd set it up but it only works on one side. It's going to be like relatively dumb. So I would suggest that you don't do that. But then again, it really depends on driver ergonomics. So as programmers, you guys should maybe take into account how your driver wants the thing to feel and use that to sort of update your drive system. But yeah, this kind of shows like how logic could be important in your code. So yeah, I guess that's a good example and a good thing that I could sort of teach you guys, and great question. So if there are any more questions, feel free to ask them. If not, I'm going to end the recording now. And it was good. Good session. Hope you guys learned something. Yeah, adios, guys. I think it's